Hi, and welcome to LabVIEW Basics number 1. My name is Grady King. If you don't have LabVIEW installed already on some sort of computer, go ahead and check out my LabVIEW installation tutorial. If you've already followed that and you got LabVIEW installed, then you're good to go for this video. I've done this a few times before in the past to some newer programmers, so hopefully this isn't too hard to follow. It's going to be a little off the cuff, but hopefully it's a decent enough structure to where it's easy to follow. So let's just go ahead and get started. Let's see. All right. So whenever you open LabVIEW, you're going to see this Get Started screen, and you're going to see, make sure you have this FRC logo somewhere in here. It might look a little different depending on what version you have. But let's just go ahead and let's make a new project to contain all of our VIs. So if you go to File, New, there's this New panel, and what we want to do is just make an empty project for now. Whenever you're making an actual robot project, it's going to be a robot project, and there's a few other things here that you're going to be using in the future, but let's just go with empty project. So this is going to be the Project Explorer. This is where a lot of your VIs are going to be clumped together into one project, which is especially important in LabVIEW because everything is in one project. So let's go ahead and make our first VI. Now a VI is a file that contains your code, basically. It's just a chunk of code. So let's go ahead and do that. If you hit this new button up here, it'll open up this panel again, and we're going to go ahead and create a blank VI. VI stands for virtual instrument, by the way. So let's make a blank VI and make sure it's added to the project. Excuse me. So you notice that there's actually two windows that open up, and they're both a little bit different. One is called the front panel, and the other is called the block diagram. The LabVIEW is structured in a way where information comes in and out on the front panel, and all of the code behind it is in the block diagram. So let's start making stuff. So the way to make anything is to right click, and you might open up this menu. If it looks a little different than this, if you don't see these labels and stuff, that's actually pretty important to see. So if you go to Tools and Options, and then go to, let's see, Controls and Functions palettes, change this palette to Category, Icons, and Text, and that'll make it a lot easier to find things whenever you need to find them. So now, if you right click, you're going to see something like this. And you'll notice there's a bunch of different things here. Let's go ahead and make your first thing in LabVIEW. So let's go into the numeric folder and make a numeric control. And that's make sure you're right clicking on the front panel, and there you go. You notice that this shows up. There's a number inside and there's a title. You can call it whatever you want. I'm going to call it whatever you want. And you see there's a number in here, and something showed up on the block diagram as well. A few controls just before we start talking about what this actually means. Left clicking on something will drag it around on both the front panel and the block diagram. You can use a left click box or left click and drag to select multiple things. And if you hold down a control and drag on an object, it actually duplicates it, which is really useful whenever you're making big things. And then Control Z is undo, just like normal. Control S can save, and that's really the basics they need to know. Okay, so let's talk about data types. So if you've ever worked in a programming language before, you know there's a few data types that are really integral to computers in general. So the first type is numeric, which is what you see here. It basically contains any number you want. And there are actually two types of numerics. There's something called a double or a float, and an integer. And so integers are essentially, if you know from math class, there's no decimal after the number. It's just like 1, 2, 3, -1, -3, etc. It's just the number without any decimal. And then doubles or floats have decimals. So you can see if you, this is actually, if you look here, that actually says double right there, and that means that it's the double type. So you can actually put in a decimal here, and that's a valid number there. You see right there. So it contains decimals as well. There are a few sort of weird things about doubles that can be a little confusing, but you don't really need to worry about that right now. The next numeric type, oh, by the way, if you want to change whether you're in double or integer, what you can do is go into right click on your numeric control, go to representation, and there's a bunch of different representations here. The most common type of integer is long, and you see that it turns blue. Blue means that it is a integer, and then orange means that it's a double or a float, some sort of decimal. The next type of data type is Boolean, and you see this, it's just the next folder here. Booleans are true or false. It's basically a bit. So it's either false or true, and you can see that here. And Booleans are green in the block diagram. And then the third type of primitive sort of data type is a string. So we can go to string and create a string control. And this just contains any sort of text, numbers, etc. They're a little less used in FRC robotics, but you'll still be using them quite a bit. And so all of these things here are called controls, and that's because you control it on the front diagram and it outputs onto the block diagram. So you see there are arrows on the right side of these blocks. That means that there's data coming out of them. There's a second type called an indicator, which basically takes in data on a block diagram and it displays it on the front panel. So if you go to numeric and create a numeric indicator, you see that it's sort of a different variable, different name, and you see there's an arrow coming on the left, and that means that it takes in data. And the way that we could connect these two is just by, you see that little wire spool, click on the right side of this right here, and you can drag it over to this numeric indicator, and you see that creates a wire, and that means that there's data actually flowing through from one side to the other. And if you want to actually, this doesn't mean that code's running, that just means that that's what the code's going to do. If you want to actually run this code, then we can just hit this run button in the top left corner here on either the block diagram or the front panel. Excuse me. If you hit run here, you actually see that the data actually ran through this wire and went right here. And we can do the same thing for Booleans. So let's create a Boolean, create a round LED that's a Boolean indicator, and we can do the same thing for a string, create a string indicator. And let's just go ahead and wire these in the block diagram, and you'll see that whenever we run the program, the data from these controls is passed into the block diagram and goes through to these indicators. And there's actually a thing called highlight execution, which allows you to see this actually happening. If you click on that and hit run, you'll actually be able to see those little dots. I don't know if you can see that in the recording, but you'll be able to see it on your screen. There's these little dots flowing through the wires showing that it's passing data through. And so let's get into some basic operations. So let's go ahead and delete this. Or actually, let's save this. So go ahead and hit File and Save, or do Control S, and you'll be able to save your VI. So I'm just going to go ahead and create a folder on my desktop. Just call this the Mars programming video VIs. And you can call it whatever you want. I'm going to call it VI1. And so there you go. You've made your first VI. And go ahead and get rid of highlight execution. So let's go ahead and close, and let's make another VI. So create a new and blank VI. So we got front panel and block diagram again. And let's get into basic numeric operations. So if you right click on the block diagram, you see there's some different things to the front panel. That's because there's more functions. So let's create two numeric controls that we can pass data into, and then one indicator that shows whatever result we get. So let's create numeric control. I'll just call this A, and let's make another numeric control, call it B. And then let's make a numeric indicator and call it the output. So you'll see on the block diagram we get all three of these on the block diagram, and let's make the code for whatever's on this front panel. So let's say we wanted to add these two numbers together. It's pretty simple. If you right click and go to the numeric panel, there's this add block, and you can just plop that in. And you'll see there's two little dots on the left side and one dot coming out. And that means that there's two inputs and one output on this block. So let's just go ahead, click on the right side of this A and bring it into the add. And let's do that the same for B. And you'll see that they're both connected into this block, and there's one output coming out. And that means that these two values are going to be added together and outputted into this output block. So let's put in two numbers, say, I don't know, 4 plus 6, and hit run, and you get the expected result. And this can also be used for float numbers, so put in just some values there, and you get the result. You'll see what you. And yeah, that makes sense. There's also other numeric operations. So if you just click this and hit the backspace or delete key, gets rid of it, and you'll see there are these loose wires everywhere. The way to get rid of these, which show up often whenever you delete something, is just to hit Control B, but you can also select them and delete them individually. I like to do Control B because it cleans it up really nice. Let's go ahead and right click on the block diagram and go to subtract, and wire this in. And it does the thing that you'd expect. Same thing for, let's delete, Control B, go to numeric multiply. I think you know what's going to happen, but I'll just demonstrate for you. There you go, multiplies. And Control B removes that. Go to numeric, divide, and that'll also divide. So those are some basic numeric operations. You'll notice that this is some sort of, this is kind of like the division that you'd see on a calculator, but there's also a different sort of division that you might have used in elementary school, which is called quotient and remainder. So let's do that. Let's delete that. And quotient and remainder is only for integers, really. And quotient and remainder is also called integer division. So if you go to numeric and go to quotient and remainder, you see there's the two inputs on the left side, but there's also two outputs. So let's drag these in here. And this only really works for integers, so let's just put in some integers. And we can also change these data types to be integers, change it to long, like that. And you'll see that these change to blue to indicate that they're now integers and not doubles. And so there's actually two outputs here. There's one that says IQ, and that means the quotient. I think QI is how you're actually supposed to read it. And then R is the remainder. So if say you ever did 6 divided by 4 in school, you might have learned it was 1 remainder 2. Excuse me. And that's actually exactly what this block does. If we actually create 2 outputs here, if you control left click, you'll create a second one. So let's create a quotient and remainder. Quotient and remainder. Ooh. It's gonna be kind of annoying to do remainder. And change these to be, in representation, change these to be integers. These can actually display doubles. If you pass it in here, you'll see that there's a red kind of block there, a little circle, and that means that it's just converting between integer and float. Be careful of that whenever you're designing your code, because it can make some interesting results. But if we now do this, you'll see that this is really what happens. You'll see that it's basically exactly what I was talking about with that quotient and the remainder. And that can be useful for example, if you want to see if a number is even or odd, you can divide by 2. And so if you do 2 divided by 2, you'll see that your remainder is 0. If you go to 3, your remainder is 1. And if you go to 4, remainder is 0 again. So if you do A divided by B with this integer division, 0 is even and 1 is odd, and that can be kind of useful. That's just one of the ways to use this. I'm gonna be right back. Alright, let's move on to some Boolean logic. So let's go ahead and save this. Just call it numeric operations. Did not spell today. There we go. And close that out. And let's make a new VI. And let's talk about some Boolean logic. So let's make a VI with 2 buttons. So right click on the front panel, go to Boolean and create a push button. I'll just call this A, and you can control left click to create a new control of the same type. And let's see, and let's create a LED. This is the Boolean indicator, and we'll just call this output. So if we wanted to combine these 2 Boolean values, remember that Booleans are true and false. One way to do it is called an AND. So let's say if I wanted a robot arm to move if the driver was giving a joystick input and the sensor said that it was safe to do so, then it does the thing. So let's do the AND. So let's right click here, go to Boolean and do AND. And this is exactly what AND does. It's if this and that are true, then the output's true. And we can show that off here. So if they're both false, then obviously it's not going to do anything. If one is true, both of them aren't true, so it's not one and the other are true. But if one and the other are true, then we get the true. And if this one's false and that one's true, then both aren't true, so it's going to be false. Another thing that you can do is called OR. So let's say if maybe it moves automatically. So it's like if the yeah, let's just say that it's always safe to move the arm, and we want to move if the driver's giving a joystick, or if there's some sort of camera that gives a good signal in order to move the arm. So let's do that. So let's remove this and do Control B to remove these loose wires, and then we can go to OR, and that's what OR does here. Excuse me. if one or the other is true, then it's going to be true. So you see if it's false, and if both are false and we run, it's going to be false. If we hit just A, we get true. If we do both, then it's also true. And if just B is on, then it's true. So basically, if one or the other or both are on, then the output is going to be true. There's also something called not, which is very useful. Excuse me. Basically, let's go into Boolean logic. Here's not. Essentially, if you pass in a true, it becomes a false. If you pass in a false, it becomes a true. So this is useful for basically doing the exact opposite of whatever's coming into it. So you see here it's true, but if any of these are true, then the output's going to be false, which can be pretty useful if, let's say, if either of these are true, then that means that it's unsafe to do something, so the output should be false to disable that thing. And there's some more complex Boolean logic that you can do, but that's basically with those three operations and or a not, you can create all Boolean logic, basically. And yeah, so that's Boolean logic. That's a very important thing to learn, and super important in terms of deciding what to do in a robot. So let's save that VI with Control S and close out of that one. Let's go to the next VI. And so this one is going to be our first structure. And if you right click on the block diagram and go to structures, you see there's a bunch of structures in here. We're going to talk about the case structure first. So let's say you have two different things you want to do, whether something is on or off. So if like a sensor is on, you want to give a different value out, and whenever something's false, you want to do something else. So this is what the case structure does. Essentially, there are two different cases. There's false and true, and there's this, I forget, yeah, it's called a case selector. Essentially, whatever comes into this left side, oops, sorry, got an alarm. Whatever comes into the left side of this question mark, that means that it'll select what code it wants to run. So if, let's create a, okay, sorry about that. I ran out of disk space. So, all right. So yeah, if you want to run different code depending on whatever comes into this case selector, then that's why you use a case structure for. I created this Boolean push button, and I'll call this the input. And if I just drag this in here, that'll create the case. And so let's say in the false case, let's pass out like a string. So let's go into string, create a string constant. And that's where you can just create a string. So let's just call this, I don't know, Mars2614. Let's say if it's false, you want to pass it out Mars2614. And if you want to do true, then it passes out 2614 Mars. Yeah. There you go. And so all I need to do is create an output. So drag it to the edge here. And oh yeah, we need an indicator to connect it to. So let's go to the front panel, create a string indicator. All right, call this output. And I'm gonna drag this out here. And let's drag this through this border and out here. And you see that it's not filled in there. That means that there's not something connected in some of the cases. So we just need to connect this one here. And there you go. So if it's false, if the input's false, it'll run this code. If it's true, it'll run that code. And you can see that if you hit excuse me, highlight execution. Let's pass in the false first. And you see we got Mars2614. Let's disable highlight execution. we get Mars 2614, and if we pass in a true, we get 2614 Mars, which is exactly what we're programmed it to do. And you can see that happen if you hit highlight execution. If you pass in a true here, it'll switch to the true case and it'll show the code running. And if you switch to false, you see it switches to the false case here and it passes through. So that's how you use a case structure. You can have as complex of systems as you want here. Another thing you can do actually is pass in different data types to this case selector. So one thing you can do is actually pass in a number, which vastly increases how many cases you can have. You can have basically infinite cases. So if we create a numeric control, and this has to be an integer, you can't pass in a double into a case. So let's right click, change this to a long, which is an integer type, and you pass this in here. You see it changes this selector label at the top. We have 0 and 1, and if you right click, you can add a case after, and you can create 2, or you can create 3 or 4. And this vastly increases the amount of cases you can have. So if we right click and create a constant here, we can create a new string constant. So we can call this, I don't know, 26 Mars 14. I don't know, 26 1 Mars 4. I don't know, I'm making stuff up at this point. Make this one Mars. And then, so whenever you pass in the number, it goes to that case. And if we increase by 1, you see we go to the first case, go to the second case, and you see this allows for some pretty complex logic if you want to use it for that. And so that's case structures. So let's say that case structures, and close that out. And let's move on. And this one is going to be just as useful as case structures in basically determining what to do based on data. So for this, let's create 2 numerics. Let's make this A and the other one B, just like before. But this one is going to be numeric comparisons. So let's go to the comparison folder here. You can actually hit this and pin it, and then it stays open. So let's first go to the greater than. So this kind of does what you excuse me, kind of does what you'd expect. If you put in A and B, basically determines if A is greater than B, and it passes it out as excuse me, sorry, passes it out as a boolean. So if you actually hover over this and right click and create an indicator, it'll actually automatically create an indicator of that type, which is pretty useful. And I'll just call this output. And so it basically just determines if A is greater than B. So, whoa, that's not what I wanted. So we pass in 5 and 2, it's going to be greater than. 2 won't be greater than 1. Obviously not. So this is pretty useful. There's also greater or equal, less or equal, which are all very useful. And a way that you can very quickly change between them, if you right click and go replace comparison, there's actually built-in functions here to allow you to switch between these very quickly. Just like that. So like less than or equal to, see, it's just like that. One thing, there is this equal, and this can be very useful in determining whether 2 numbers are equal, but you got to be careful. Obviously if you pass in 2, but you got to be careful about using them with doubles or floats. For example, if one is like 2.0001, it's not true, even though it kind of looks like it is, it isn't. And that's one thing about floats, is that, or doubles, is that those decimals matter whenever it's comparing. One way that you can fix this is by basically subtracting one from the other and then determining how big that difference is. So the way that I normally do it is, if you go to numeric, subtract, then this will be some sort of small number, and it could be negative or positive. So if you do absolute value, that makes it a little bit easier to compare. So if you go to numeric, absolute value. So let's say this is like, this is going to be like 0.0001, and we don't really care about those tiny digits. So if we just see if this is less than a tiny number, then that means that it's pretty much equal, right? So if we go to, if it's less than, let's say if it's less than like 0.01 different, like this, then it's basically equal, and that's what this output's going to be. So you see here, there you go. So if it's 2.02, it's not equal. 0.01, it's not equal, or it is equal, yeah. So that makes it so that these tiny decimals don't really matter. But if you're just using integers, then you don't need to worry about this. But that's something really important about comparisons and using equals. There's also things like equal to 0, greater than 0, pretty useful things here. Excuse me. That's about all I want to say about comparisons right now. Let's put that into, I misspelled that. Ooh, I can teach you about renaming VIs. If you go to save as, there's all of these options. There's also a rename option, so you can rename it here. Comparisons. And that's useful because if you just change the file name, sometimes permissions or like dependencies can be bad. But all right, so that's good on comparisons. Let's go to some of the most important things here, which is loops. Now, loops are incredibly important in robotics because it's something called real-time programming, which means that it's continuously running, basically. Code is always running continuously over and over and reacting in real time to whatever's happening. So there are two different types of loops. If you right-click on the block diagram, go to structures, there's the for loop and the while loop. If you've ever used something like C++, Java, whatever, you know what these are. For loops, let's type this out. For loops will go for a specific amount of loops. So this n up here is loop count, and if we right click on the left side, create a constant, we can pass in the number of times that something runs. So if we pass in 10, whatever happens in this loop is going to happen 10 times. So this I actually says what iteration we're on, and so we could literally just pass that out. And let's create an indicator actually to show that. Let's go to make indicator, pass that out. And yeah, one thing about loops is that there are different ways to pass numbers out. So it's called tunnel mode. I want to pass out the last value that comes out of the loop, and that'll pass it out. And you'll see it's on its 9th iteration, which loops actually start at 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, that's 10 loops. So that runs for 10 times. This is useful for doing certain operations like on, let's say, arrays or something. If you want to do something to each value of an array, you can use a for loop or something like that, which if you don't know what an array is, don't worry, I'll teach you later. But the for loops are a little less often used, but it can be used in like low level stuff like that. So let's go ahead and save that. And let's go to the more important form of loop, which is the while loop. And this is the most commonly used loop in LabVIEW, or especially in FRC. So if you right click, go to structures, and go to while loop. Basically, a while loop runs while something is true. So it'll continuously run while something is true. And the thing that determines whether the loop runs or not is this thing down here called the loop condition. Essentially says stop if true or continue if true. So let's say if we want to make a loop run forever, which is kind of what we want to do on a robot, because there's no reason to not be running code on a robot if it's on, then what we do is we can just pass in a Boolean value here that's false. So if it's stopping if it's true and it's always passing in a false, that means that the loop's going to run forever. So that's pretty nice. That means that whatever is running inside this loop is going to be running, yeah, it's going to be running forever. So for instance, if we wanted to, let's say we go back to that example of adding two numbers. For instance, let's add two numbers, and we can create controls here by right-clicking. You see, creates two controls, and we right-click and create an indicator. If we hit this run button now, you see that it says that this button looks a little different, which means that it's running continuously. So if I make changes here, it's immediately going to show up. And yeah, if you want to see how many times the loop is running per second, you can go to this eye here and create an indicator, and you'll see it's running kind of fast. It's running pretty fast. Basically, it's using however much my CPU gives it, which it's in the I think it's in the billions at this point. No, it's in the 100 millions. But yeah, so that's running pretty fast. One thing about the computer that we use on the robot, which is called a RoboRio, is that it doesn't have too much processing power, and that's kind of on purpose. So one thing that we might want to do is limit how many times this loop is running, because it doesn't really matter on my computer, because I have a very powerful computer, how many times this loop runs, which it ran 370 million times. But on something like a RoboRio, we might want to restrict how much that loop is running. So one way that we can do that is we can make the loop wait every loop cycle before it can go to the next cycle. So if you right click and go to timing, there's this block called the wait block. And what you do is you pass in a number of milliseconds to wait, and it'll wait, excuse me, every loop cycle, it'll wait that amount of time and then run again. So if we create a constant here, we can pass in, let's say, 1,000 milliseconds, which is 1 second. So let's go. You'll see it'll wait an entire second before the loop runs again. So you see this updates every second. Most often, the fastest you're going to run a loop is 20 milliseconds. And that's for super important things, like super vital controls or something like that, such as like your drive base or something like that, where you want to have super fast controls. 20 milliseconds is about the fastest you're ever going to need to control anything. And you'll see it's running pretty decently fast, but it's definitely not using up all of my CPU, which is very important when it comes to programming for FRC robotics. Let's see. Another thing that's important is something called the tick count. And so let's say we wanted to know the amount of time between whenever this loop started and the current time. So let's go into the timing thing and go to tick count. And let's just show what this shows. So let's go ahead and run, and you'll see here. You see this is kind of a big number, but it's showing the number of milliseconds. I think since your PC booted or something like that, it's sort of an arbitrary number. But the thing that you can do is you can find the time at the beginning of the loop and then keep that time and compare it to the current time, because you can see it counting up how many milliseconds has passed. So let's see. If we put this outside of the loop, this is going to run once, and then the loop is going to run. And then all this code is going to run continuously. So if we pass this in, this number is never going to change because it runs once and never again. So what we can do is we can take this number, which is where the loop started, and compare it to the current time inside the loop, which is going to be greater than the time here. So let's go ahead and go to numeric and subtract. And so we're taking the current time minus the time that we started at, and let's create an indicator here. And you'll see that it's counting up the number of milliseconds since the loop started. And if we divide by 1,000, that actually gives us the number of seconds. So let's go ahead and divide by 1,000. And you can see that, this becomes actually pretty useful very quickly. And let's make this a double indicator so that it shows decimals. And you can see here, it's counting up the number of seconds. So this is very useful. We use this a lot in there's a mode in robotics called autonomous, where the robot is entirely controlled by the code and there's no driver input. And this is used a lot in this because we want to time how long things happen and only run for a certain number of milliseconds or seconds or something like that. And so this is something that we use all the time in autonomous, as well as controlling things, etc. This is super useful. So be sure to get used to this sort of timing scheme because it's very important. And you also notice that if we change this loop count, or this wait time, it doesn't influence this sort of counting. You see that it goes up by about 500 milliseconds. It goes over just a little bit sometimes. But yep, that's everything to do with while loops and timing. One thing that is very useful in loops is something called a feedback node. If you've ever used a programming language before, you might be a little confused by LabVIEW because there's not really anything like variables that you write to once and then it's stored. So, well, there is something like that, but this is out of the scope of this tutorial. So one thing that you can use is something called a feedback node. So let's go into structures and go into feedback node. Now a feedback node, it does a very special job. Essentially, whatever is passed into the right side comes out of the left side, which is kind of interesting. If you look at all these blocks, things come into the left side and they come out the right side. This is very special because what it does is it takes in whatever comes into the right, stores it, and then it comes out of the left side. And so if you wanted to store a number, what you could do is excuse me, sorry, pass in that number and then continuously pass it back into the feedback node, and it'll actually keep the number. So let's say we have a numeric and we want to store like the first number that comes into this numeric. There's a thing called the initializer terminal on this feedback node, and that's the value that first comes out of this feedback node. And if we loop it back into itself, this wire actually is going to have that number forever, which is actually pretty useful. And you can also change that number by changing whatever comes into this wire. So that's a useful way to store numbers and to basically keep numbers based on like certain conditions. So let's say we wanted to pass in, here, let's make a new VI and make an interesting sort of VI. I'll just call this while loop. Let's say if we wanted to add a number, let's say we wanted to add 2 to a number every loop cycle if a boolean is true. So let's get that boolean in here. So we'll call that input, and we'll pass in our starting number, and we'll create our output. So we're going to be looping this, and let's pass in a false here so that it runs forever. So let's see. If we go to structures and create a feedback node, we can start our number on this number. So that'll initialize this. And then if this number is true, then we're adding 2 to the number. If it's false, then we'll keep the number the same. So a way that we can do that is we can change the code that's running based on this Boolean value with a case structure. So let's go here, go to case structure, and pass this number in. So this is our number at the beginning of the loop cycle, so let's pass that in here, like that. So if it's true, we want to add 2 to the number. So let's get our addition and add the number 2 to the number and pass that out. And then I'll go to our numeric. And if it's false, we don't want to do anything to the number. So we can just pass the number through. And we need to store this number back so that we can modify it in the next loop cycle. So let's put it back into this feedback node. So, and let's create a wait so that we can kind of like process what's going on. So let's wait for like 500 milliseconds between each number. And let's start at number 4. So if we start running, nothing's really happening right now, but the loop is currently running. If we hit true here, it starts actually counting up. And you can, if we highlight this execution here, you see that this number is coming into the right side of this number, coming out here, and it's getting added to 2. 2 is getting added to it, and it's coming out as 28, going to our numeric, passing back into our feedback node, and you'll see that it's going around and around. And if we turn off the input here, you see 34 is coming out. This turns to false, and now 34 is just continuously looping in and out of this feedback node. So this is very useful for passing numbers in between loop cycles, modifying numbers depending on inputs and outputs, etc. So that's feedback nodes. That's very important. A second way to actually do this, which is very similar, is something called a shift register, which is essentially the exact same structure, just specific to loops. So let's delete this for right now. And let's right click on this edge of the while loop and add a shift register. And so you see these arrows. Basically, whatever you pass into the left side here is basically the initialization of that feedback node, very similar to the feedback node. So if we pass that into here, this number that's here starts as this number, and then whenever you pass a number into this right side of this right side of the shift register, then in the next leap cycle it passes back into the left side. So we can basically do the same thing here. Let's pass it into the case structure. If it's false, we want to keep the number the same. So what we do is we pass it back into here. So essentially whenever it's false, the number comes out here and then just gets passed right back into the shift register. Whenever it's true, we just pass it into the addition. So it comes out here, 2 gets added to the number, and then it comes back into this right side and then leaps back around. So if we start this again and disable highlight execution, we'll see that the same behavior is happening again, and we can highlight execution here. So whenever this is true, the number comes out here. In this case it's 24, 2 gets added to it, becomes 26, and then comes into this right side. Excuse me. And whenever input is false, now this number is 30, comes in here, case structure changes to false, and it comes back into this arrow. So that's 2 different ways to do essentially the same thing. It really depends on your preference. Whichever one is less confusing to you is the one that I recommend you use. But yeah, that's some pretty complex behavior in just some simple blocks. And call this feedback nodes and shift registers. And that's actually the end of this video, so we're going to head over to the challenges. Challenge 1 is to calculate the area of a circle with the radius from a front panel numeric control called radius, and the output displayed on a front panel numeric indicator called output. When the radius is 1, the output is pi. When the radius is 2, the output is 12.56. Radius is 3, output is 28.27, etc. Your second challenge is to make a calculator using 2 numeric controls, x and y, and a separate numeric control determining the operation called op. 0 will add x and y, like so. 1 will subtract x and y. 2 will multiply x and y. And 3 will divide x and y. And display the output on a numeric indicator called output. Your next challenge involves passing in a number n as a numeric control. If the number is even, divide the number by 2. If the number is odd, triple it and add 1. Use the newly calculated number as n and repeat. Calculate the number of loop cycles it takes for n to get to 1. And remember that loop cycles start at 0. For example, an n of 3 takes 7 loop cycles to get to 1, and 2614 takes 177 loop cycles. This is alternatively known as the collatz conjecture. Good luck and have a great day.